All right, any questions over chapter 13? In other words, if I gave you this, find the equation of the line that goes through these 2 points. Yes, you're right. Find the two. Okay, here's the equation of the line going through the points 1, 5, -7, -3. Find the equation of the line going through the points 1, 5, -7, -3. This is the end of the 9th week too. And we're doing really good because we're gonna finish chapter 14 too. So we're in really good shape. So what do you need to find the equation of line? What 2 things do you need? You need a point and you need a slope. Those are the 2 basic things you need to find the equation of a line. We have a point, we choose either one of these. Do we have a slope? Not yet. Can we find the slope? What's the formula? Very good. And then you're right. Let's label x1, x2, y1, y2. Good morning. We just started. So we're finding the equation of the line going through these 2 points. To find the equation, we need to have a point and a slope. So we got to find the slope. So x1, y1 are the xy components of the first point. x2, y2 are the x and y components of the second point. So x1 is 1. That's x1. x2, -7. y1, 5. And y2, -3. Once we find those, let's plug and play. That's y2 minus y1. So y2 is -3 minus y1 is 5. x2, which is -7 minus x1 is 1. In the top, they're both negative, so the answer is negative. Add the numbers. 5 plus 3 is 8. Same on the bottom. They're both negative. Add the numbers. 7 plus 1 is 8. The negatives cancel. 8 divided by 8 is 1. So the slope is 1. So we found the slope. We need to find the y-intercept or the b value. of this equation. Y equals mx plus b. So how do we do that? This is step 3. Step 4 is choose either point the slope and plug them into our equation. Plug them into y equals mx plus b and solve for b. So we have our slope. We have 2 points, 1, 5, -7, -3. It doesn't matter which point you pick because they're both on the same line. So always pick the easier one. First or second, which one is easier? Yeah, let's keep away from negatives. So these are my x and y components of the equation. That's m. Plug them in there. That's my m. This is my x. This is my y. So y is 5, m is 1, x is 1, we need to solve for b. 1 times 1 is 1. Subtract 1. 5 minus 1 is 4. Okay. We now have m and b. So just plug them in. Into y equals mx plus b for those 2 values. So we have b equals 4. We have m equals 1 from above. Just plug those in here. And then you have your equation. So those are the steps of finding the equation of a line. Want to do another one? Okay, let's do another one. Find the equation of a line going through 0, -5, and -3, 7. Remember, we need 1 point and the slope. Which point do you want to use? We have 2 of them. Okay, it's always easier if something has a 0, it's easier than that, but let's use -3, 7. Because if you use the one that has a 0, that takes care of part of the equation already. Now we got to find the slope. Let's label x1, x2, y1. What is x1? So that's the first point. It's 0. x2, -3. Oh, second point. y1 is -5. That's the y value of the first point. And y2 is 7. It's the y value of the second point. So we have 7, which is y2, minus a -5, -3 minus 0. Negative and negative becomes a positive. So 7 plus 5 is 12 over -3. Since there's only one negative, the answer is negative. 12 divided by 3 is 4. So my slope is -4. We also need the y-intercept. Do we have the y-intercept yet? So how do we find the y-intercept? Yeah, that's why we did this. If you fill it up this way, use this point, use that slope. Let's find B. This is X, this is Y, and this is M. So Y is 7. M is -4. X is -3. We got to find B. Negative is positive. 4 times 3 is 12. Subtract 12. 12 is bigger, so it's negative. 12 minus 7 is 5. Didn't we know we had a y-intercept already? What's the location of the y-intercept? 0, -5. Because to find the y-intercept, set x equals 0, and whatever the y is, that's what we had up here. So we have Our y-intercept is -5. So now we have everything we need right here. We have M and B. From earlier, M is -4, so y equals mx plus b. M's there. B is there. -4x minus 5. There's your equation. So that's if I give you 2 points. If I give you a point and a slope, if I give you a point and a slope, then you just start off from this part here. I'll give you a point and a slope. Just start with that, find B, and go for it. What if I asked you now this? Find the equation of the line in slope-intercept form going through the point -8, 3 and is parallel to the line 2x minus 3y equals 10. Find the equation of the line in standard slope-intercept form going through the point -8, 3 and is parallel to the line 2x minus 3y equals 10. Remember, what 2 things do we need? A point and the slope. Well, we have the point, so that's given to us already. Do we have the slope? Can we find the slope? All it tells us that this line that we're finding has to be parallel to this equation. If they're parallel, what has to be true? Yeah, parallel lines have one, same slope, and different y-intercepts. So since they're parallel, that means they have to have the same slope. What's the slope of this line? Can't find it until we solve. You can't find it until you solve for y, because we have to put it in this form. We have to find whatever is in front of x. So with this equation, solve for y. Solve for y and find the slope. Since we know it's parallel, since our line has to go through this point, has to be parallel to this. If they're parallel, they have to have the same slope. So we have to find the slope of this line. Subtract 2x from both sides. So get rid of the 2x first. There's a negative in front of the y, so I change all the signs. And I divide by 3 each term. Since our equation, our line has to be parallel to this one, what's the slope? What slope does it have to have? Has to have a slope 2/3. So we take whatever equation that's given to us, set equal to y, find the slope of that line. Since we're asked to find parallel, it's the same slope. If we asked to find perpendicular, what would it be? If it's perpendicular, has to be flips of each other in opposite signs. But we'll worry about that next. So we have a point and a slope. Plug that into here. Our y value is 3 from the point. Our slope is 2/3. The x value is -8. And we have to find the y-intercept. We have an equation here. We have to solve for b. Since we have a fraction and an equal sign, what do? What have we always done? Every time we see a fraction and equal sign. Besides just staring at it, what do? What's the LCD? 3. It's the only denominator. What do we do with the LCD? Multiply each term by the LCD. So 3 times 3. 3 times 2/3 -8 plus 3 times b. What's our third step? Reduce. Always cancel. When you have fractions and you multiply, always reduce before you multiply. So the 3 goes into 3 once, it disappears. So what we have now is this. We got rid of the fraction. Okay, what's our next step? Multiply, get rid of the parentheses. Again, we've been doing this for 8 weeks now. Hopefully some of it has sunk in. 3 times 3 is 9. Positive times negative is negative. 2 times 8 is 16. 3 times b. Solve for b. 16 plus 9 is 25. Divide by 3. B is equal to 25 over 3. I'd leave it at that because it'll make it easier to look at you could, but I think the computer will take it if you leave it like this. Because I'll show you why. Now, since we have our y-intercept, we have our slope from earlier, which is 2 over 3, and my y-intercept is 25 over 3. Remember, our slope is 2/3. Now I plug those into the equation. Two-thirds x plus 25 over 3. So there's our equation that goes through the point -8, 3, and it's parallel to the other line. Let's use the same information, but this time let's look for a perpendicular line. Find the equation of the line going through the point -8, 3 and is perpendicular to the line 2x minus 3y equals 10. To do this, remember we need a point and we need a slope. Do we have a point? Yeah. -8, 3. That's the point our line has to go through. Do we have a slope? Can we find it? Yeah, because it has to be, the slope that we have has to be perpendicular to this line. So we have to find the slope of this line first. So find the slope of this line. How do we do that? Solve for x, solve for y. So we subtract 2x from both sides. There's a negative in front of the y, so we change all the signs. And divide by 3 each term. So this is the line. It's our line goes to this point, has to be perpendicular to this one, which is this. Has to be perpendicular to this line. So what's the slope of this line? Now the slope of this line is 2/3. So what is the slope perpendicular to that line? Remember, the symbol for perpendicular is upside down T. Two conditions have to apply to be perpendicular. First off, has to have opposite sign. So this one's positive, ours has to be negative. Has to have opposite signs. And two, they have to be flips of each other. This is 2/3, ours is 3/2. So that is our slope, because it has to be perpendicular. So our slope is -3/2. Now we have to find the y-intercept, which is the b value. This is the first thing we have to do. This is the second thing we have to do. So we plug it into this equation. What is y? This is the y value. M is -3/2. That's your slope. This is the x and the y. So the x value is -8 plus b. We have fractions and equal sign. So we got to find the LCD, which is what? 2. It's the only denominator. Multiply the LCD to each term. So 2 times 3, 2 times -3/2 times -8 plus 2 times b. So each term, put a 2 in front of it. Reduce. Only ones that cancel are those 2's. Write down what we have. Multiply to remove parentheses. 2 times 3 is 6. Negative times negative is positive. 3 times 8 is 24. Plus 2 times b. And then solve. Since b is our only variable, we solve for b. Subtract 24 from both sides. 24 is bigger than 6, so it's negative. 24 minus 6 is 18. Equals 2b. Divide by 2. So b is equal to only one negative. 18 divided by 2 is 9. That was our second objective. Our first objective, we had to find the slope of the line we're looking at. Then, once we find that, we had to find the the y-intercept. Third, we find the equation of the line. Our slope is -3/2. Our y-intercept is -9. Just plug it into y equals mx plus b. We had to just plug in m and b. -3/2x minus 9, since this is -9. And there's your equation. That's our answer. This moving around of equations is important because that's all we're going to do in chapter 14. Any questions so far? That sums up chapter 13 right there. Finding equations of lines, finding slopes, finding this. Yes, okay, yes. We have two symbols. I'm glad you asked again. We have parallel. When you the parallel, we use that symbol. Perpendicular, we use the upside down T. Okay, so let me show you what if you weren't here yesterday, let me go and review real quick what those mean, why those are important. When you have two lines, L1 and L2, we can have 4 outcomes possible. Note, when we say solution, when we have two equations, two lines, a solution is where the two lines cross or meet. So when we talk about solutions, we're going to see where they cross, where the two lines are exactly the same. All right, so there are 4 things that can happen. Two lines can be parallel. This is line 1, this is line 2. They never touch. Since they never touch, we have no solutions. But how can you tell if two lines are parallel? They have to have the same slopes. And because of that, they also have to have different y-intercepts. Because if we had an XY graph here, here's one y-intercept, there's another one. So if you have two equations of lines and you solve it and you put it in this form, put it in slope intercept form, compare the slopes, solve it for y, compare the slopes. If the slopes are the same, look at the y-intercepts. If the y-intercept, if the b values are different, then the lines are parallel. That means they have no solution. If they're the same line, if line 1 and line 2 are the same, then they have infinite solutions. every point is a solution. If it's the same line, what has to be true? The slopes have to be the same, and the y-intercepts have to be the same. Because they're the same line. They have to have everything the same. So if the slopes are the same, you have to look at the y-intercepts. If they're different, they're parallel. If they're the same, it's the same line. So that's either all or nothing in the solutions. So those are the all or nothings. These next two, only one solution. If two lines are perpendicular, that symbol means it's a 90-degree angle. Oops, sorry. If two lines are perpendicular, that means they have a 90-degree angle between them. The perpendicular, and we use the upside down T for that symbol. This one we use the slanted lines. So because they cross at one place, we only have one solution. So what do we know about these two lines? We can't say much about the y-intercept because they can cross on the y-axis. So the only thing we know about these is the slopes have to be negative flips of each other. They have to have different signs, and they have to be reciprocals of each other. If that happens, then they're perpendicular. Then they'll have only one answer. Anything else, you have line 1 and line 2. Anything else, all we know are the slopes are not the same. If the slopes are totally different and not reciprocals of each other, then we know we're going to have one solution somewhere. Okay, so this chart is very important. If I gave you two equations and you set them to slope-intercept form, look at the slopes. If the slopes are the same, it's one of these two. If the slopes are not the same, it's got to be one of these two. And this is what I did yesterday also. Here's the slope. Tell me the slope perpendicular or parallel, and then tell me the slope perpendicular. So if my slope is 2/3, what is the slope parallel to it? Yeah, it's the same, 2/3. What's the slope perpendicular? Very good. -3/2. We have to take this one, flip it, and change the sign. If I give you this. Yeah, the parallel is the same, it's -4. What's perpendicular? Positive what? You're missing one part of it. Because this one is 4/1, isn't it? No, this one's negative, so this one has to be positive. So it has to be opposite sign and flip. Zero. The slope that has slope 0 is a horizontal line. So what's the slope parallel? What's the slope perpendicular? Because this one is what? It's 0/1. So this one has to be 1/0. undefined. Yeah, if the slope is 0 here, the perpendicular one is undefined. Yes. Yeah, because the perpendicular to this is flip this, it's 1/0, which means it's undefined. So you'd put undefined. So if it's undefined, the parallel one is undefined, and the perpendicular is 0. It's the opposite of it. And what do these two lines look like? If the slope is 0, what does the graph of that line look like? Well, let's say it has to go through this point. 3, 2. Has to go through that point. So 1, 2, 3, 1, 2. Has to go through that point. And the slope is 0. What is the graph of that line going to look like? That is slope 0. If the slope is undefined, going through the point 3, 2. If it's undefined, it looks like this. Because remember, in the slope equation, the only way it can equal 0 is if the top is equal to 0. The only way the top can equal 0 is if what is true. If both of the y values are the same. So if I had 2 points, -1, 2, 3, 2, I notice that the y values are the same. Since the y values are the same, the top part's going to be 0. So for the slope is 0, it's a horizontal line. In undefined, the only way an undefined slope can be true is if the bottom is equal to 0, which means all the x values have to be the same. So we have 3, 2, and 3, -1. If the x values are the same, it goes vertically. It's undefined slope. So let's summarize everything we did in chapter 13, the different types of equations we have, different forms. Summary of the forms of linear equations. Here's the first one. What is that one called? This is called the slope intercept. Why is it called the slope intercept form? Because m is the slope and B is the y-intercept. That's the first one. The second form that we have y minus y1 equals mx minus x1 is called the point slope form. It's called the point slope form because we have a point x1, y1, and we have a slope m, hence point slope. The third type, ax plus by equals c, where a has to be positive. This is called the standard form. And the x and y intercepts are found. To find the x-intercept, what do you have to do? Set y equals 0, solve for x. To find the y-intercept, set x equals 0, solve for y. So the x-intercept, y equals 0, solve for x. So you're going to have a point x0. The y-intercept, set x equals 0, solve for y. So you'll have 0, comma, y. The next one, y equals b. Since there's no x value in there, this is the equation of a horizontal line. Where slope is 0 and the y-intercept is at 0, 0y, 0b. Call it the y-intercept. Going through the point AB. So if I give you a point and I say that the slope is 0, the equation is simply y equals the y value. And the last one, equation is x equals a. That's a vertical line. The slope is undefined. And the x-intercept is a comma 0. going through the point AB. So that's everything in this chapter. Again, it means nothing unless you try to do some of the problems yourself and apply it. Because yes, it's easy when I explain it up here. But if you don't touch it until next week or 2 weeks from now, this is all going to be Greek to you. All right, so that does it for chapter 13. Good morning. Chapter 14. Systems of linear equations. This is chapter 14. When we say a system, we're talking about two or more equations on the same graph. So when we say system, we're talking about two or more. We're going to keep our limit to ours to only two equations. Because we're dealing with linear equations. The number of equations in a system is limited to the degree of the equations. The number of equations in a system is limited to the degree of an equation, of the equations. In this class, in this case, when we talk about degree, we're talking about the number of variables in an equation. It also matters the number of terms in an equation. So since we're dealing with linear equations, our equations look something like this. We only have two variables, x and y, 3 terms maximum. Because we only have two variables, we can only have two equations. We can have line 1 and line 2. Since we only have X and Y, that's all we can have. That means we can have two of them. For example, quadratic equations look like this. Y equals. How many variables are in there? No, the variables. Here's a Y, X squared, and A, B, and C. The coefficients are always numbers. It's just that instead of putting numbers there, it's just any general numbers, integers. So we have X squared, Y, and X. We have three variables, which means with quadratic equations, we can have three equations in our system. Yes. So do what? Since we have three variables, we can have three lengths, and so on and so forth. It builds up from there. Cubic equations will have this exponent tells us what kind it is. If the biggest exponent is a 2, then it's quadratic. What's our biggest exponent in this equation? What's the power of this one? 1. Because the biggest exponent on X is 1, it's linear. If the biggest exponent on X is 2, it's quadratic. If the biggest exponent on X is 3, it's cubic, and so on and so forth. We're going to limit ourselves to these, to linear equations. Like we talked about last time and earlier this morning. 4 things can happen. They could be parallel, they could be perpendicular, they could be the same line, or they could be just 2 lines somewhere on the plane. All right, so let's look at this. To solve systems of linear equations, notice now I limited myself only to linear equations, systems of linear equations. We have 3 ways to solve them, which pretty much covers chapter 14. The first way, this is section 1. Solving by graphing. Remember, when you have 2 equations, what constitutes a solution? where the two lines cross or overlap. So the first section, we're going to talk about graphing. Section 2, solving by substitution. We're going to take one equation and put it inside the other equation. Section 3, solving by elimination. There's actually another method called solving by matrices, but that we cover in algebra. These are the basis. Actually, if we have time, I'll show you the matrix one. It's a lot easier than all these put together. And in section 4 is going to be applications of these. So let's look at section 1. By graphing. Here is a system. I have two equations. Line 1 is that one. Line 2 is for simplicity purposes, hold on here. Let's make this a 6x and make this a 9. Because I don't want to give you fractions just yet. The graphing method, here are the steps. Place both equations into slope-intercept form. What is the slope-intercept form? Very good. Y equals mx plus b. Excellent. This is 9. I change it to a 9. Then graph both equations on the same graph. Six x plus 3y equals 9. 3x minus y equals -5. Those are my two equations. You have to put them into slope-intercept form. So go ahead and put them in slope-intercept form. In other words, solve for y. Subtract 6x from both sides in the first one. And divide by 3. Negative 2x plus 3. So there's my first equation. Okay, I would prefer you guys not bobblehead. By this point in the semester, 9th week, you guys should know how to solve these yourself. If you don't know how to solve this yourself, then I don't know what I could do, because this should be rudimentary to you right now, moving things around. And solve the other one. I'm gonna try to keep you guys from always bobbleheading. You got them both? So both equations. Y equals negative 2x plus 3, y equals 3x plus 5. You subtract 3x from both sides, and then you have to change all the signs because there's a negative in front of the y. Change all the signs. Now we graph both of those equations. How do you graph these equations? Anybody remember? Start with the y-intercept and then follow the slope down 2 over 1. There's line 1. Do the same thing with the second one. Plot the y-intercept, which is 5. 1, 2, 3, 4, 5. And follow the slope up 3 over 1. Huh? No, it's just 3x, it's positive 3x. So it's up 3 over 1. Over 1. So you put a dot there. Connect the two dots. It's a lot easier if you use ID cards to draw these graphs. It's instead of using big books and stuff. Would you go ahead and do what you want? I mean, if you want to use that, but your ID card's a lot smaller, a lot easier to move around. See, now you see the limitation of this method. Where do they intersect? What's the answer? Yeah, because if my graph is correct, it's right between 3 and 4. And if you go down, it's below -1. So the problem with the graphing technique is it's only as accurate as your graph. As your graph that you're drawing on. We'll come back to this one in a minute. When we do the other two methods, and we'll see what our answer is supposed to be. Is 2, 5 a solution to this system? Is the point 2, 5 a solution to that system? How do we test it? How do you solve? Right. Plug in this for X and this for Y into both of them and see if it works. If it's a solution, solutions are where the two lines meet. So if that's a solution, it has to be true in both equations. So is it true for this one? Is it true for this one? So anywhere I see an X, I put a 2. Anywhere I see a Y, I put a 5. Three times 2 is 6. Negative 2 times positive, negative times positive is negative. 2 times 5 is 10. 6 minus 10, 10 is bigger, so the answer is negative. 10 minus 6 is 4. That works. On the other equation, 5 times 2 is 10. 10 plus 5 is 15. So that one works. So that's the way you test to see if something's a solution. Is 1, negative 2 a solution to this system? We're still in 1. I'll tell you when we move on to any of the more sections. So we plug in those points in that equation. In that equation. Anywhere I see an X is a 1, anywhere I see a Y, it's a negative 2. Negative times negative is a positive. 3 times 2 is 6. 1 plus 6 is 7. So that one works. Four times 1 is 4. Positive negative is a negative. 2. 4 minus 2 is 2. So no. 1 negative 2 is not a solution to that equation because they both don't work. Let's pick another one. Let's try another one. Find me the solution to this system by graphing. So it's just say graph this system. If you're asked to solve the graph this, to tell me the solution by graphing, what do you do first? If you don't know, tell me. Okay, that's what it's saying to you to do, but how do you do that? What do you have to do first? Solve for what? Now, look at your notes. It was just on the board a minute ago. Solve for y. Put it in slope intercept form. Solve for y. So subtract x from both sides. There's line 1. Since there's a negative in front of y, change all the signs. There's line 2. You have to. Y has to be by itself. Cannot have anything in front of it. You're solving for y, not negative y. You're solving for y. Because that means there's actually a -1 in front of it. Like same as -5 or -7 is still a coefficient. You have to have a +1. So what do these two equations tell us? Just by looking at those two equations, what can you tell me about those two lines? Are they parallel, perpendicular, the same line? Are they going to meet? What are the conditions for parallel? Are the slopes the same? What's the slope of this one? Where is the slope in this equation? -1. The slope is in front of the x. What's the slope of the second equation? 2. Are they the same? So they're not parallel. They're not the same line. Are they perpendicular? What are the conditions for perpendicular? Before you ever answer, think of the conditions. What's that? Not for perpendicular. That's the slope and the y-intercept if they're the same lines. What's that? No. Horizontal line do not have x values in it. Are the slopes the same? What's that? No, because this one's positive, -1, this one's +2. You can't change anything. You just look at the way they are. Are they the same? No, they're not equal. So that means they cannot be parallel or they cannot be the same line. The only thing they can be is perpendicular or some other. Are they perpendicular? What's the conditions for perpendicular lines? Have to have opposite signs, and what else? Have to be flips. Are they, okay, they have different signs, check. Are they flips of each other? They're flips of each other? -1 is the flip of +2? No. They're not flips of each other, so they're not perpendicular. So that means it's the last possible condition is they're just two lines that meet somewhere. Because the slopes are different, they're going to have one solution. They're going to meet somewhere. So let's go ahead and graph them and see where they meet. We're going to use these equations. The first one has a y-intercept of 4. And the slope is -1, so it's down 1 over 1. Always make the slope into a fraction. And the second equation has a y-intercept of 1. The slope is up 2 over 1. So where do they intersect? What's that location? One comma 3. That's the solution of that system. Again, you have to now go and review how to graph lines. We did that last chapter. The next section. So, okay, so for the graphing method, what is the procedure? What do you have to do first? Set both Very good. Set both equations to slope intercept form, which is y equals mx plus b. Again, mathematics is a language. You have to know these words. Once you get both equations in a slope intercept form, what do? Graph both equations. How do you graph them? Remember your equations and y equals mx plus b. How do you graph them? You already found y. That's what you did in the first step. You put it in a slope intercept form, y equals. So am I to guess that nobody's made it to chapter 13 yet? To graph equations? We're running out of time then. If your equations are in slope intercept form, plot the y-intercept, the b value. On the y-axis. From that point, follow the slope m to the next point. Connect the dots. This is the method we've been using ever since we learned how to draw graphs. All right, section 2. Solve by substitution. I'll pick one example and we'll use that and go from there. So line 1 is 5x minus 3y equals 9. Line 2 is x plus 2y equals 7. First step. Choose either equation and solve for either variable. So that's the first step. So which equation do you want to use and what variable do you want to solve for? Look for the easiest one. We're going to pick one of these two equations and we're going to solve for one variable. Do you see anything that looks easy? What's that? What do you see easy about it? Remember, you're solving for a variable. You want to get one variable by itself. Look again. Obviously, the second equation already has a letter by itself. I mean, it's not rocket science. Just look at the two equations and you see one of them that looks simplest. So I'm using the second equation. And what variable are you going to solve for? We're going to solve for x because that's by itself. To solve for x, we have to get rid of 2y. X equals negative 2y plus 7. Remember, this is from line 2. The second step. Okay, you've chosen an equation and you chose a variable and you solve for it. Substitute the equation you found in step 1 into the other equation. So in the first step, you chose one of the two equations, you solve for a variable. Now, substitute that equation you just solved for into the other equation you didn't use. So this is the equation we found from line 2. So that means we now have to use line 1. Anywhere we see an X, we put that in its place. We substitute that. That's what it means. So in place of X, I put negative 2y plus 7. Now, once you did that, solve for the only variable. In this equation, there's only a y, so solve for y. Positive times negative is negative. 5 times 2 is 10y. Positive and positive is positive. 5 times 7 is 35. Minus 3y equals 9. Combine like terms, negative 10, negative 3, they're both negative, so you add them. 10 plus 3 is 13. You lost? Are you? Okay. Let's solve it for y, so I have to get rid of the 35. $35 minus 9 is 26. Change the signs. And divide by 13. Again, all of this stuff should be nothing new to you. We've been doing this for 9 weeks so far. 26 divided by 13 is 2. So we have the y value. How do we find the x value? Plug that solution into the equation from step 1. What did we do in step 1? We picked one of the equations and solved for a variable. So this is because we now need x. That's what we're solving for. So this equation we found in step 1 was x equals negative 2y plus 7. Anywhere I see a y, I put a 2. Negative, positive is negative. 2 times 2 is 4. 4 plus 7 is 3. Those are the point of your solution. So our lines cross at 3, 2. All right, let's look at another one. Let's do another one. Using the substitution method. Obviously, I hope the substitution is a lot easier because now we have solid answers. Ooh, that's what we'll do. Let's look at the first one we did. Remember we tried to graph it and it was just a weird graph? Let's solve this one. Line 1, 6x plus 3y equals 9. Line 2 is 3x minus y equals negative 5. That was the first one we tried to do and we had no luck with it. So the first thing to do, which equation are we going to pick? Line 1 or line 2? Okay, we'll pick line 2. Which variable are you going to solve for? Very good. So we have to get rid of the 3x first. Negative y equals negative 3x minus 5. Change all the signs because we have to get y by itself. So this is the equation we'll come back to at the end to solve for y. That's step 1. What do we do with this equation now? Yeah, since we used line 2 here, we now have to look at line 1. 6x plus 3y equals 9. Now, anywhere I see a y, I put 3x plus 5 in there. So 3 times 3x plus 5. Because we know y equals 3x plus 5. Anywhere I see a y, put 3x plus 5. Solve for x now. Let's get rid of the parentheses. Positive times positive is positive. 3 times 3 is 9x. Positive and positive. 3 times 5 is 15. Equals 9. Whenever you get rid of parentheses, always combine like terms next. 6x plus 9x is 15x. Get rid of the 15, so subtract 15 from both sides. 15x equals, so 15 is bigger, so it's negative. 15 minus 9 is 6. Divide both sides by 15. X is equal to negative 6 over 15. Can it be simplified? Do 6 and 15 have anything in common? A 3. So 3 goes into 6 2 times. 3 goes into 15 5. So my x value is negative 2 over 5. So we have our x value. We're missing our y value. Where do we plug this? Way up here, where y equals the first thing we solved for. So we have y equals 3x plus 5. So plug that in for x. Negative 2 over 5 plus 5 equals y. We have a fraction and an equal sign. So what's the LCD? 5. So we multiply each term by 5. The 5's cancel. So we have 5 times y equals 3 times negative 2 plus 5 times 5. All I did is got rid of the denominator. Multiply to get rid of the parentheses. Positive, negative is a negative. 3 times 2 is 6. Positive, positive is positive. 5 times 5 is 25. Combine like terms. 25 is bigger, so it's positive. 25 minus 6 is 19. Divide by 5. So my y value is 19 over 5. So there's my solution. That's where the two lines cross. What do y'all think of this method? Much better than graphing. Because imagine trying to guess that answer if you graphed it. It'd be very difficult. So this method's a little bit easier. Let's try, before we move to the next one, let's try fractions. This is line 1. 2 over 3x plus 1 over 2y equals 6. Line 2 is 1 over 2x minus 3 over 4y equals 0. What do you think the first thing we have to do is? Get rid of the fractions. Get rid of the fractions. So the first thing we have to do is get rid of the fractions. To get rid of the, on the top equation, how do you get rid of the fractions there? What do you have to do? Find the common denominator. What's the LCD? 6. Very good, because 3 times 2 is 6. So multiply each of the terms by 6. And what about the bottom one? What do we multiply by there? 4. Because 2 goes inside 4, 4 goes inside 4. So I multiply every term by 4. We simplify, reduce. So 3 goes into 6 twice. 2 goes into 6 3 times. 2 goes into 4 twice. 4 goes into 4 once. It's gone. So my new line 1. 2 times 2 is 4. X. 3 times 1 is 3. Y. 6 times 6 is 36. Line 2. 2 times 1 is 2. X minus, since the 4s are gone, 3y. 4 times 0 is 0. Our first step was simplify the equations. Now, which equation are you going to pick to solve for? There's no easy way of looking at this. So let's look at the second equation. Or the first. I mean, pick your poison. Which one you like better? Second one or first? Second. Okay. Let's take line 2. 2x minus 3y equals 0. What variable do you want to solve for? You want to solve for x? Okay, that's a good choice because that way we get rid of the negative here. So we add 3y to both sides. And divide by 2. So x is equal to 3 over 2y. We'll come back here at the end to get our y value. So since this was line 2 and we solved for x, now we have to choose, now we have to use line 1. 4x plus 3y equals 36. Anywhere we see an x, we put a 3 over 2y in it. That's the substitution method. So here the 2 goes in the 4 twice. So we have 2 times 3y plus 3y equals 36. 2 times 3 is 6. 6y plus 3y equals 36. 6 plus 3 is 9. Divide by 9. We get what? What does y equal? So now we take this 4 we just solved for, plug it back in our first equation we solved for the x. We know x equals 3 over 2y. And we know that y equals 4. 3 over 2 times 4. 2 cancels with the 4. Put it in twice. So x equals 6. So they meet at the point 6, 4. That's the solution. That's the point both x's have in common. So are you okay with the substitution method? All right, let's try the last method, elimination. If you noticed, the beautiful thing about the substitution method, it does a complete circle. We start off with line 2, plug it into line 1, and we go back all the way back to the top and find the other value. So both equations are being used with both variables. Section 3. Solve by elimination. So section 2, we solved by substitution. We found an equation, we substitute it and use both equations that way. In this method, we're going to use both equations off the bat. But before we start that, here's what we have to make sure of. Here are the steps. Let's look at an example here of lines. X minus 3y equals 7. Or x plus y equals 5. The substitution method was we picked one of the lines, solved for a variable, plugged it into the other equation, and worked out that way. Now, in here, what we need are, we need two coefficients to be the same number but different signs. We need a variable to have two coefficients that are the same number but different signs. That's the first step. Note you may need to multiply one or both equations by some numbers to make it so. To make the top part. Because remember, you have to have the same numbers but different signs. So you may need to multiply one or both equations by some numbers to make the number, the coefficient of the variable, same number but different signs. So let's look at this equation here. Well, we have to do, what variable do we get rid of first? So let me see. Choose which variable you want to eliminate So looking at this, what variable you want to get rid of, the X or the Y? Okay, let's get rid of the Y. If needed, then multiply one or both equations by a number to give them same coefficients with different signs. That's if needed, because sometimes you may have already the same coefficients, different signs. All right, so let's look at our equation. We want to get rid of the y. So first check, do they have opposite signs? Yes. Do they have opposite numbers, the same number? This one has a 3, this one has a 1. Are they the same? No. So that means we have to do what to make them the same? The second equation, since that's a 1, we have to multiply the whole second equation by 3. We have x minus 3y equals 7. So if 3 times 4 is 12, 12x. 3 times 1 is 3, y. 3 times 5 is 15. So you can manipulate one or both equations to make them have the same coefficients but different signs. You notice now the y's, they both have a 3 and different signs. Now, if I add both equations, that's my next step. Add both equations together. Add both equations together. I was running out of space down here. Because remember, we chose to get rid of y. So this is 1x. 1x plus 12x is 13x. Negative 3 plus 3 is what? They cancel. 15 plus 7 is 22. So solve for x. X equals 22 over 13. So there's my x component. So far, so good? Because now, since you know what x is now, you can choose either of the two equations that you started off with, plug x in there and solve for y. So which one looks easier to plug into? The top or the bottom one? The top one, yeah, because it's just xr by itself. So go ahead and use line 1. And anywhere I see an x, I put a 22 over 13 in there. So anywhere I see an x, I put a 22 over 13. And I solve for y. Since we have a fraction and equal sign, we have to multiply each term by the LCD, which is 13. Remember, whenever you have fractions and equal sign, get rid of the fraction. 13's cancel. Negative times positive is negative. 13 times 3 is 39. 7 times 3 is 21. 7 plus 2 is 9. Solve for y. Subtract 22. So 8, so it's 969. Change the signs. Divide by 39. They both have a 3 in common. 3 goes into 6 twice, 3 goes into 9 3 times. 3 goes into 3 once, 3 goes into 9 3 times. So this is what your point is. That's your y value. So the x value is 22 over 13. The y value is negative 23 over 13. That was the first one we tried to do. We tried to graph that was so weird looking. That was the first one we tried to do. Horrible looking. Want to try another one? Let's do another one. Line 1. Line 2. So your first choice, what do you have to do first in this method? Choose a variable and get rid of. Because you may need to multiply one or both of them. So choose a variable to get rid of. That's a safe one. Let's try the other one. You're right. This one you multiply. What would you multiply to the second equation? 2, because you need to have this is a negative 2. This one has to be a positive 2. Right now it's just a 1, so you multiply by 2. That's the easy way. Well, let's do that first, and then we'll do it the other way. See if we get the same answer. So we have to multiply this equation by 2. Leave the first one alone. 2 times 5 is 10. 1 times 2 is 2. 2 times 15 is 30. Because they have to be the same number, but different signs. Now what do? You have a variable that has the same number, different signs. Let's just add the equations. 3 plus 10 is 13, x. The negative 2, positive 2 y's cancel. 30 minus 4 is 26. Then we divide by 13, both sides. So x is equal to 2. That's our x component of our answer. Now, what do you do with this 2? Into either one of these original equations. It doesn't matter which one. Since that's a single y by itself, let's use line 2. 5x plus y equals 15. Anywhere I see an x, I put a 2. Ten plus y equals 15. Subtract by 10. Y is equal to 5. So there is our solution. Everybody okay with that? Let's try it with looking at the first numbers this time. 3x minus 2y equals -4. 5x plus y equals 15. This time I want to get rid of the x's first. So remember, they have to be the same number but different signs. So since this is a 3 and this is a 5, and they're both positive, I have to multiply the first one by 5 and the second one by 3. But one of them has to be negative. Doesn't matter which one, so I'll make the second one negative. Five times 3 is 15x. Positive and negative is a negative. 5 times 2 is 10y. Positive, negative is a negative. 5 times 4 is 20. You have to multiply all the way across. Negative times positive is a negative. 3 times 5 is 15x. Negative, positive is a negative. 3 times 1 is 3. Y. Negative times positive is a negative. 3 times 15 is 45. So far, so good? Now, since we have the same numbers, different signs, we can go ahead and add these two equations. These two will cancel. Negative and negative is a negative. 10 plus 3 is 13. Negative and negative. 45 plus 20 is 65. Change the signs. Now we divide by 13. $65 divided by 13 is 5. Because 5 times 3 is 15, carry the 1. Since I have y, I can go back to here and pick any one of these two equations, the original equations. Which one do you want to pick? First or second? Okay, first one. So we choose line 1. 3x minus 2y equals -4. Anywhere I see a y, I put a 5. Negative, positive is negative. 2 times 5 is 10. Add 10 to both sides. Ten minus 4 is 6. Divided by 3. X equals 2. So we get the same answer both ways. You get the same answer no matter what variable, what line you pick, but one side's going to be less work. What's that? Well, yeah, well, it all depends on which variable you pick off the beginning, off the bat. Because we picked here originally, the y, we multiply by 2 on the bottom one. It makes it much easier, yeah. So there is no wrong choice. It's just, it'll make, so one way to make it more time expensive. Let's look at what this one will look like. So what variable will we get rid of? Y. All right. So we'll get rid of the y. Right now it's a 1. What do we have to multiply to the top one? So it's the same number, but different sign. But they both have the same sign right now. They're both negatives. So I have to multiply this one by -2. Because I have to change this sign to be a positive. Because that's a negative, this one has to be positive. Negative, negative is a positive. 2 times 1. So negative, so it's negative 2 times 3 is 6, x. Negative of negative is a positive. 2 times 1 is 2. Negative, positive is a negative. 2 times 4 is 8. We have the same number, different signs. If we add them, what happens? The -6, +6 cancel. 2, -2 cancel. So we have 0 equals 12 minus 8 is 4. Uh-oh, what does that mean? Means the lines are parallel. If there's no solution, that means they never touch, so the lines are parallel. So if this ever happens, if you get to a point where all the variables are gone and the two answers don't match, those are parallel. So again, if after you multiply and add everything together, if all the variables disappear and the numbers are not equal, then they're parallel. You have no solutions. Let's look at this one. Pick a variable. X. To be honest with you, that's usually the hardest thing to choose, which one you want to pick. But yeah, you pick X. So that means this is a 1, this is a 2. What do we multiply to the top one? So it's the same number, but different signs. Right now it's a +1. We need it to become a 2, but it has to be a -2 since this is a +2. We multiply by -2. Negative, positive is a negative. 2 times 1 is 2. Negative and negative is a positive. 2 times 3 is 6. Negative, negative is a positive. 2 times 2 is 4. And leave the bottom one alone. If we add them all together, what does that tell us? Infinite solutions Same lines. You're going to be asked in your homework to tell me whether the systems are consistent or inconsistent. And then you're going to be asked, are they dependent or independent? If they're consistent, they have at least one solution. If they're consistent, they'll have at least one solution. So if they're inconsistent, they have no solutions, parallel lines. If they're dependent, they'll have the same graph. If they're independent, they have different graphs. So if they're dependent, they have the same graph. If they're independent, they have different. So this last one we did, is it consistent or inconsistent? Yeah, because it has at least one, has infinite solutions. How about the graphs? Are they the same graphs or different graphs? Yeah, because it's the same line, they have the same graph. So it's dependent. It's consistent and dependent. This one here, the parallel ones, is it consistent or inconsistent? Inconsistent. Do they have the same graphs? Yeah, they're like this. So they're inconsistent, but they're dependent because of the same graphs. They're just offset. That's it. That's the hard part of chapter 14. Next thing we'll do is we'll look at, actually, I may change it to do, no, crap, it's too late. But I was going to look at doing inequalities. But now we'll look at applications next time. Yes. Yes, I totally agree with you.